Okay, hello everyone, and welcome to an introduction to Jetstream2. Let me go ahead and share my screen. Where is that? I've done that ahead of time. Here we go. Okay, can everyone see that? Okay, I think I can see it in the Lava Lab. So yes, hello, welcome to an introduction to Jetstream2. Today we're going to be covering some introductory aspects of using um, this national resource. And so here, before we begin, if you want to participate in the interactive portion of the tutorial that we're going to be doing later on, where we're working within Exosphere, and you've created an Access ID, then and you have not shared it with us in the form that we sent out, then go ahead and share it with me in the chat, and I should be able to add you to it, and hopefully it'll process that before um, we need to start using it. Um, this specific tutorial also involves the use of VLLM and logging into a Hugging Face account in order to um, use specific models. So if you're not participating, then don't worry about that. But if you want to follow along with the slides, then I'll go ahead and share the link here in the chat as well. However, you should be able to pull that off of the QR code at the bottom of the slide. So I'll give you a few more seconds for that. CSNet error. I think you're already added to here. Let's see. Yeah, if you've already filled out the form, then you should already be on the allocation. So you should be good. So next. So this is what we're planning to cover today. First, I'm going to be going over a broad overview of Jetstream2. What are its features and use cases? A selection of different options to interact with it, though the tutorial will be covering one specific interface, some limitations, what you're not allowed to do with Jetstream2. And I also want to cover um, going through how to work with your access allocation in order to use Jetstream2, because the Jetstream2 resource is gotten through Access, which I will talk about. And I just want to show you the whole workflow, basically, from from creating an account towards actually getting time on the resource. Then I'll show you logging into Exosphere, and then we'll go into the demo. So in the tutorial, we'll be going over Exosphere actions, things like creating and accessing an instance, how to install software, how to create and attach storage and transfer data to and from your instance. And if you want to save an image of your instance, and in order to create more, and just some best practices. And then going into the part that requires the Hugging Face account is serving up a web chat interface using VLLM, OpenWebUI, and Caddy. Now that part we may not be able to get through a certain amount of it just because there's an issue going on with Jetstream2 in which software packages are having trouble um, installing with apt, and the some of the later steps in that uh, we aren't able. Some of the later steps in that involve installing packages, so we'll get as far along as we can, but we may not be able to finish that. So, to begin, what is Jetstream2? It's a high-performance cloud computing environment which provides resources to researchers and educators across the US through the NSF-funded Advanced Cyberinfrastructure Coordination Ecosystem Services and Support, or ACCESS program. And that's a lot of words to throw at you, but in short, Jetstream2 is just a nationally available resource on which researchers and educators are able to create virtual machines that exist on the cloud, and they can work with those virtual machines, which we also call instances. And so that's what Jetstream2 is. And so Jetstream2 is designed to be user-friendly and accessible to both advanced users and those who have had little to no experience with high-performance computing resources. That's one of the reasons why, at Research Cyber Infrastructure at UH, it's one of the first resources that we will direct new users, people who are new to these natural resources and access to, because it makes a great on-ramp to access as a whole and these other resources. Now, Jetstream2 is it's targeted towards smaller institutions as well as those within EPSCoR states, such as the University of Hawaii, and it's run by the Pervasive Technology Institute at Indiana University. So, another reason why we help people with Jetstream2 is because the University of Hawaii is one of the regional partners to Jetstream2. So there's the primary cloud infrastructure, which exists at the Indiana University, but then there's also one located at the ITC building in Manoa, and so there's one at ASU, at the Texas Advanced Computing Center, and as well as Cornell University. Now, by default, users who gain time on Jetstream2 through ACCESS will be working on the primary cloud. In order to gain access to any of the regional clouds, you have to specifically be invited to that or request permission to gain access to those. So some features of Jetstream2 is that well, primarily it allows you to create and administrate your own virtual machines. It has access to the internet, so you're able to install and configure your own software. You have a lot of control over these instances, and you're able to configure them through a web shell, which I'll show you later, a virtual desktop if you enable it during the creation of your instance, or through SSH on your own machine. It is an on-demand resource with no queues or runtime limits. Now, if you are familiar with the COA HPC at UH, then you'll understand what makes Jetstream2 unique is that, unlike a batch system where you're queuing up jobs and you're given a certain amount of wall time before that job has to finish out. Um, as long as you have the resources and you're using it, you know, to serve out something or work with your VM, then it then an instance can remain continuously on. So you're limited primarily by the resources you have and not by a specific time limit. And so that's one thing that makes Jetstream 2 stand out compared to what might be more of a typical HPC system. Um, and of course, these resources are available at no cost to the end user, thanks to support from the NSF. So you aren't, for example, you aren't paying out of pocket, out of your grant in order to gain time on Jetstream 2. It's something that you apply for what's called an allocation, which we'll get into a bit later. And so long as you're awarded that allocation, then you have a certain amount of time that you can um, exchange resources for and actually spend time on Jetstream 2. So this is a picture of Jetstream 2's primary cloud infrastructure. It's an 8 petaflops computing system currently at 17.2 petabytes collective storage. They have 384 compute nodes with 128 cores and 512 gigabytes of RAM each. Their GPU resources they have 90 nodes, each with four A100 GPUs. However, you are also able to, by default, that's what you have access to. You do not have access to the L40S H100 and multi-GPU A100 nodes that are actually also technically part of the system, but they are available by request with proper justification. And so they have 32 large memory nodes with up to 1 terabytes of RAM, and then their storage is NVMe. So this is a look at the specific flavors or resources on each type of resource. So a CPU instance can be as small as one CPU core with 3 gigabytes of RAM, or go up to 64 CPU cores and 250 gigabytes of RAM. Um, by default, though, they are capped at by default they're capped at 64, but it's possible to get up to 128 CPU cores. Again, by request and with proper justification. Um, the large memory instances are basically comparable to the CPU instances, but with double the amount of RAM for the matching types, and there's no real parity at the smaller CPU sizes. The GPU instances, they used to have uh, 1/5 of a GPU that you could run. Now I believe it ranges from a quarter to a full A100 GPU. And by default, you have access to 1 terabyte of storage. But this is for the root disks. In order to gain more than the default storage on the root disk, you're going to have to put some resources into Jetstream 2 storage resource, which which we'll cover soon. So some use cases for Jetstream 2, you can use it to teach a course. You can create and configure an environment that you can um, uh, let students loosen, and you can have them, practice network security. And if they mess something up, then you can delete an instance and spin something up again. You can use it to work with code, write and execute and test things all within these VMs, or you can use a GPU instance to train and refine machine learning and large language models. And you can also use it to host a file server or database. One use case, one example use case here is the Hawaii Climate Data Portal. It contains decades of atmospheric information, including rainfall, temperature, and now fire risk. And so the Hawaii Climate Data Portal is actually hosted on a Jetstream2 instance. So that's one example of Jetstream2. It's running on the cloud and has access to the broader internet, and then you can access it. And so you can if you have the slides open and you're following along, you can click on this link and it'll take you to the Hawaii Climate Data Portal and you can take a look at that. So now we're going to cover three interfaces for Jetstream2. The primary user interface for Jetstream2 is called Exosphere. It's the most user-friendly, but it's also the most limited. It gives you access to uh, your VMs through an app called Guacamole that has a web shell or a virtual desktop, and as well you can SSH into your instances. This is what we're going to be covering in the tutorial, but I thought I'd introduce you to um, the other interfaces as well. So Horizon is an advanced user interface. Now Jetstream2 is built on a software called OpenStack, and Horizon is the default user interface for OpenStack. It's the most feature complete of the interfaces, but it's nowhere near as user-friendly as the Exosphere interface. And so, there's going to be some things that might be simpler or easier to accomplish in Exosphere, but some things that can't be done in Exosphere, in which you might want to use Horizon. And it supports virtually all of the functionality of the OpenStack API. And so that's why it's so powerful. But there is a third interface in development. This one is an alpha. This is called Cacao. It's also for advanced users, and it's created to make it easy to build clusters on Jetstream2 or to use Jupyter Hub. And so if you want to check it out, there are links up here on the slides to the documentation to learn more. But we're going to be focusing on Exosphere today. So, some limitations to what you're able to do in Jetstream2. It's for research or education use only, so not for commercial use. You're not, hosting a personal website. Um, Jetstream2, it's not primarily a storage or archival service. So yes, you can host files, you can um, get storage, but it's not just a place to it's not for cold storage, and you have to renew your allocation every year. And I believe an allocation by default can be renewed up to 5 years, and then you have to put in a separate allocation request. So, you can't just use it and expect to put all of your data on it and not have a plan for some point in the future in which you're going to have to offload that data to somewhere else. Um, and Jetstream2 is also not designed to host data protected under, HIPAA, FERPA, ITAR, or any other federal or security or privacy laws. And just keep in mind that, Jetstream2, it gives you a lot of control over what you can do with your VMs, but you're also responsible for administrating it. And so you're given enough control in order, but it allows you to mess things up and make your instances vulnerable, right? And also the images on Jetstream2, aside from uh, experimental Windows images, they're primarily Linux based. So keep in mind, uh, what types of software you might be limited by and unable to install based on that. So now I'd like to spend some time covering the Access program. Jetstream2 is a nationally available resource which is obtained through the Access program, which was established and funded by the NSF to help researchers and educators utilize advanced computing systems and services. But it's not the only resource. It's one of many, and you can follow this link if you want to view some of the other resources which are available through Access. Um, the nice thing about Access is that you can have this one Access account, which usually will be associated with your institution. So you can link that with your institution, and then you can use this one access account to gain time on a variety of national resources, depending on your needs. And so this time on these resources, they are parceled out through what are called allocations of access credits. And so applying for an allocation is sort of like applying for a small grant. This is what the process for going through access to get time on these resources looks like. So many of you, if I've added to our allocation, have already completed step one, which is to create your access ID. Um, and so next you would be selecting a project type based on your needs, and um, Access arranges this just in order of size. So explore, discover, accelerate, and maximize. And we'll cover what that means in the next slide, I believe. Um, so once you know what you need based on um, how you're planning to use it, you can prepare documents and materials and submit your allocation request. And you can, and so then after a waiting period, you'll either get um, you'll either have your allocation awarded, or it'll be rejected. And then once you receive your access credits, then you can so they're idle until you actually exchange them for a given resource. And so I'll show you what that looks like later. So this is what you get at each level for each allocation type. So the smallest allocation that Access gives out is called an Explore allocation. It gives you 400,000 credits, Access credits, followed by Discover. which is 1.5 million. Accelerate is twice that at 3 million. And then maximize really it's for very large projects and it depends on the project. Um, so an access credit is just this sort of abstracted currency which you can exchange for time, typically called service units on these resources. So this information is the exchange may be different depending on the resource, but for Jetstream2 specifically, you can exchange one access credit for one service unit, and a service unit is one CPU hour of time on the resource that's running it. Um, and so it's not just, are you actively using it? Are you running a program or software or something on it? As long as you have the instance up and running, it is spending those service units. And so, for example, if you had a really small instance that only has one CPU core, then if you ran it for a day, then you would have spent 24 service units. But you could also go through many by having, a multi-CPU core instance also running for that amount of time. Or you could have multiple different instances all running at the same time. And so that racks up how quickly you are burning through your resources. And so service units are the unit for CPU, GPU, and large memory resources on Jetstream2. But Jetstream2 also has a storage resource where one access credit will get you 1 GB of storage. And so the way that the storage resource works is slightly different in that you don't actually burn through these. It's more like, you exchange it for a certain amount of storage and then, those credits are kind of spoken for. And so you have that amount of storage until you, um, relinquish it basically, right? And so if you are interested in sort of trying to figure out how many service units you expect to burn through for any given project that you're planning on running, there is a link to a usage estimation calculator in Jetstream2's documentation here, where you can select different sizes of instances, how many you're running at a given time, and how active it is, hours per day, days per week, how many weeks, and at the end of time, how many service units are you going to have spent. So this is very useful. So an allocation must be requested by the PI of the project, which is any educator or researcher at a U.S. academic nonprofit research or educational institution. And you can also list co-PIs, and actually a graduate student is able to request and explore or discover allocation, so long as they have a letter of collaboration from their advisor. Allocations must be renewed annually, so you do have to prepare a report every year for what you've used the allocation for. And so you shouldn't be too nervous about necessarily getting the allocation size right the first time, especially if it's your first allocation, because projects can be upgraded by applying for the next level allocation tier if you find that you don't actually have the resources you need. So if it's your first allocation, then I would definitely recommend applying for an Explorer allocation to begin with, so you can, you know, gain experience working with these resources. And if you find that you need more, you can apply for something larger. And another advantage is that the difficulty of applying to larger allocations increases. There's more and more requirements. So the Explorer allocations actually are the requirements for applying are pretty easy, and you hear back from them a lot more quickly. So this is the allocations page, and actually I may just show you uh, what it looks like here. So I'll drop the link here to the home page for Access CI so I can show you how to get there. So I'm going to go to the allocations page up here. And if you're not logged in, it's just going to show you this, right? So I'm going to log in here, and Access uses CI logon. Now, when you created your Access ID, you will have you'll have selected your institution as an identity provider. But once you've created your Access ID, you can log in with Access CI. So I'm just going to leave that selection and log on. Okay, here. So I enter my Access credentials. That's asking me for a dual push. There we go. So when you log in and you go to the allocations page, which you can also get to by clicking on My Projects anywhere in the um, allocations section of the Access website. If you have not been added to any allocations, or if you don't have one of your own, then you're not going to see anything listed here. But if you are part of an allocation, then you're going to see these listed here. And so um, this is the allocation that we'll be using for the tutorial part of today's workshop. And here you can see an overview of information, the PI of the allocation, and some history of exchanges made and what resources are on the system. You can see that we have some storage and in Jetstream2 CPU and GPU. But here's where you actually manage the resources in your allocation. So in the credits and resources tab, it'll show you an overview visually of, how your credits are distributed. So you can see um, I have 5,000 Access credits exchanged for 5,000 gigabytes, and that's at 100% because you don't exactly burn through those resources, but you do here in the CPU and GPU resources. And then you can see that all credits currently parceled out have been exchanged for resources. So that's why it says 0 access credits or 0 credits available to exchange. So you do need credits in order to request more, in order to exchange them for time. So, for example, so here you can see the list of resources, what units they are, gigabytes for storage or service units, um, for any compute resources. You can see how much I've spent here and how many I have remaining. But if so these actually are editable because if, for example, I went in here and reduced this number, then you can see I gain back those access. Well, I haven't submitted the exchange yet, but it's telling me, how many access credits I have available to exchange. So if I wanted to, I can now go over here to this list of all these other resources. You'll notice it's not just Jetstream2, right? Delta, Darwin, Delta AI. But here, for example, I don't have any resources exchange for Jetstream2 large memories. But for, say, I had a project which required a lot of RAM. So I wanted to exchange some resources for Jetstream2 large memory, and then I could I could exchange, however many access credits I have here. So I could put in 10,000, right? And then I would enter a brief justification for that and submit it for approval. However, I do not need large memory resources, so that's just an example. I'm going to reset this form. But that's how you exchange access credits for these resources. And you won't be able to log into these resources until you've exchanged credits for them. So keep that in mind. So it's important to be aware of what this whole workflow from start to finish looks like. And then this is where, for example, any of the users who are participating in the tutorial, this is where I've added those users. So I typed in their access usernames and I added them here. And you can see in the columns, you can give them access to all of the resources, or you can be selective about it. Say they don't need access to storage, maybe they don't need access to GPU resources. You can uncheck that, and then they won't be able to create a GPU instance, for example. And so only the PI, co-PI, or an allocation manager will be able to do this. Users just have access to the resource. They don't really have the ability to manage anything on the access allocations page itself. And then here you can see history of credits that have been exchanged for that resource. Um, but also, if you need more credit. So for example, this is originally an Explore allocation. Uh, it was parceled out in, so it is in total 400,000 credits for the entire allocation, but it was parceled out as 200,000 initially. So you can, if you're running low, you can request a supplement here. So, one of your options is if you have a lot of credits exchanged in a resource that you're not using, you could instead go back to that resource, reduce the amount of credits, and then exchange it for a different resource. But if you find that you're low and you need more, then you can instead go to request a supplement. Here, there's a whole 200,000 on this allocation that has not um, been parceled out yet, and so you can request a supplement. But also when you get near to the end of your allocation, then you can also request an extension on that or request a renewal, right? So you'll have to renew that every year if you plan to do it for multiple years. But that's what managing your allocation on Access looks like. See if there's anything I haven't covered in slides. No, so now we can uh, go over logging into Exosphere. So I'll drop this link in the chat for anyone who wants to follow along with this. You will need your Access ID, and actually, if you have not, if you do have an Access ID, but you have not shared it either in the chat or in the form that I emailed out, then you will not be able to log in. So if you have filled out the form as of, I think, yesterday, then you should be fine. Let's see if there are any new responses. I think I do have one. So let me go ahead and add that. Okay. And hopefully that processes in time for you to be able to use it. So what you would do is you would go to that link, which will take you to the Exosphere homepage, and you won't see any cards aside from add allocation if you haven't logged in yet. So you will click on that card and then select add access account and then log in with your access credentials. And once you do, you will, assuming that you've been added to an allocation or you have one of your own, you'll be given a selected edition of those which are available to you, and then you check those which you want to use. And so for today's tutorial, if you're participating, then you should have been added to allocation code CIS 250 so if you don't see that available, then you either the adding the user has not been processed yet, or I have not added your username, and so you can share that. Uh, like you can share your access ID, and they should be able to add you. And then a card for the allocation will show up, and then you can click on that and go to Exosphere. So I'm going to actually do that here. And here we go. So, um, so for those of you participating, this is the part where you get to spin up your own instances and actually be able to work on them. Once we're past the Exosphere tutorial, then I have a set of commands to make it easier for you to be able to follow along that you'll just be able to paste into the terminal. So you can use these QR codes, or I'll just share these links in the chat as well. And that's yeah, so for the moment, that's the last of the slides, and so we're just going to be going over here. And wait, yeah. So when you uh when you log into your allocation, this is what the Exosphere user interface will look like. So here at the top, you will have your allocation code, what you're logged in as, and So you'll see here, this shows you how much of your allocation that you've used up. Um, well, actually, that's kind of misleading. So here, keep in mind, this is only showing you out of the credits that you have exchanged for the resource. So Exosphere has no visibility into the entirety of your access allocation. It'll only show you, you know, out of how many resources that you've exchanged, how many have you spent? So keep that in mind. So you have here, because of exchange resources for um, Jetstream2 CPU and GPU, it has different bars. So these would correspond to, for example, basically this, right? So we're kind of looking at the same thing here. And I'll go into slightly more detail about all of this, but I think we should start by creating the instances because that's going to take a few minutes. So, oh, actually, I don't need to be here. So here at the top right, you can click on create and you have a few options here. Here I'm going to select instance. So instance is for creating an actual VM. And you have two options here at the top. By type, which basically creates a completely fresh VM for you to configure on your own, or by image, where if you've pre-configured something, then you can create an image of that and then start from there. So here you have options for Ubuntu and Red Hat. However, there are some steps that take an extra long amount of time without much happening, which aren't really conducive to a workshop. So I've done a little bit of setup in um, uh, instance and created an image of that. So instead of creating one fresh, we're going to go and find workshop LLM image and create an instance of this. And um, so once you reach here, this process is identical to if we just went back and created one fresh. So if you selected Ubuntu or Red Hat, it would take you to this exact same screen. So you're learning all the same stuff, Exosphere wise, right? So here I'm going to create something, easily identifiable. Let's say, I'll use my access ID, and then, you know, JS2 workshop, right? So it's going to be easy for me to find. But you could choose a random name if you wanted to, right? And then it'll show you what image this is being based off of. And so here we have a selection of what Jetstream2 calls flavors, which is, what are the specs of the virtual machine going to be, right? And so here you have the name. So for CPU instances, these are all called M3 dot something. So the smallest one has a single CPU, 3 GB of RAM, and the default root disk of 20 GB, right? Um, Up to 2XL, which has 60 CPUs and 250 GB, right? So if, for example, a user has not been assigned CPU resource, then they shouldn't be able to see these, or at least they wouldn't be able to select it, right? So the reason I can click around and select these is because I have, in here, I have the CPU resource checked on my name. However, for this tutorial, the plan here is to go with the G3 medium. So these are partial GPU instances, and this is a full GPU. Both of these are made available by being added to GPU resources, right? And so here you can see, if you want, how much VRAM it has. And you'll notice that they have a larger default root disk at 60 gigabytes. And one of the reasons, at least, that partial GPUs and full GPUs are separated is because once you create a full GPU instance, you cannot resize it. So just keep that in mind if you are using GPU resources, because you can, no, under most circumstances, you can resize an instance, but you can't resize a full GPU instance. So keep that in mind. And so generally speaking, you know, if you know what kind of compute power you're going to need for your project, my recommendation would be to use the smallest one that has all of the specifications that you need, rather than going for the largest flavors available. And the reason why I say that is because the larger instances are also going to be the ones that are most likely to have low availability, because there's going to be a lot of other people who might be, using them for a particular project. And so if you find that you're having trouble creating an instance of a particular flavor, usually, much larger, then what you can do is you can go to the status page. And so I'll share this in the link in the chat as well. And so the Jetstream2 system status and information page is a really good page inside the Jetstream2 documentation to get an idea of what is the current availability of resources on Jetstream2. So it's in Jetstream2's documentation, and what you can see here is, okay, so here's, a 100 GPU, which by default is the only one that's available on a GPU resource, but you can also see availability of L40S, H100, and, general purpose and large memory. So you can see this instance, whole node, R3.XL, there's none of these available, right? So you wouldn't be able to create one. Here, the one that we're using for this particular tutorial, there's 207 available. So that's plenty for this group here, right? And so you'll notice that that number shrinks as partially just because of the absolute availability in the system as a whole, but also partially just because for really intensive workloads, those are more popular. And so just something to keep in mind, this is a good page to check in on if you want to know that, the resources are available for you to create the flavor of instance that you want to. But here I'm selecting G3.medium, so we shouldn't have any issues with that. And so here you have the option to choose an alternative to the default root disk size. And so what it means here by volume backed is that you need to have some of your access credits exchanged for Jetstream2 storage resources in order to be able to do this. So way back in the earlier in the slides when I said, you're given 1 TB of storage by default, that's what you get here, right? That's what gives you these root storage disks. If you want more, then you have to exchange credits for more. But I'm just going to be using the default here. You can create multiple instances at once if you have the need, but we don't need to do that here. For demonstration purposes, I'm going to select yes on enable web desktop. This is what gives you the option to log into a remote desktop and do things graphically if you find the need. But not all applications are going to need something like that. And I do not touch the advanced options. If you're an advanced user, then you can change things around. Um, so you can choose not to deploy Guacamole, but Guacamole the um, is the software that runs the web desktop. It's what allows you to access your instance through the browser as opposed to through the terminal on your machine. So if if you knew for sure that you didn't need it, you could choose not to deploy it. If you know that you don't want to install operating system updates, you can choose not to, right? But I'm not going to touch any of this here. So I'm going to hide that. One more thing um, I want to mention before I create it, you may find yourself in a situation where some of these options are grayed out. Um, I'll show you where to look for why later, but most likely there's going to be some sort of resource in your allocation that you are running short on and trying to create one of those instances um, exceeds the amount of remaining resources that you have. And so that's probably, if you find any of these are grayed out and you're unable to select them, that's probably why. So you can go out and you can go back and look through Exosphere to see if you're running up against the limits of what you have. But here I'm going to go ahead and create this based on the image. And so here, this filters out just the instances that you've created. So, it right now, this one's building. Then it's going to be yellow and stay setting up. And this usually takes a few minutes, and then once it's ready, it'll be green and it'll say ready, right? While that's working, I'm going to show you the rest of the interface. So here we have the option to create an SSH public key or public IP address that you can use in order to, access your instance from outside from the internet. But here I'm going to show you creating a volume, which is much quicker than creating a virtual machine. So volume, as I said, requires resources exchanged for um, Jetstream2 storage and for you as a user to have access to. So I'm just going to say LOSGO workshop example here. I'm going to call it that to make it easy to find. And the size is not um, I'm not making it for any specific purpose other than to demonstrate, so I'll just leave that as 10 gigabytes and I'll create it. And so you'll see that this volume is available pretty much instantaneously, and it's not attached to anything right now. But I do actually have an entirely different instance up and running already. So, why don't I show you attaching that here? So here you can go into the instance and click on attach. And you also have the option to delete it here, but so you can see this is available. I'm going to attach it to this instance that I created earlier for a different reason, and I will attach it here. All right. So here, now the volume is attached to that instance, and actually it'll show you where the mount point is. So if you want to go into that storage, here it is, media volume, and then the name of the storage, right? And so you'll find it if you log into that instance. Now, one of the advantages of using volumes as opposed to, creating a very large root disk is that you can, you can attach a volume to an instance, you can work on the data in that volume, you can manipulate it, and then, you can detach it and attach it somewhere else, right? And so um, that's something good about the volumes that um, you can attach it to different instances, and you can even, uh, you know, detach it from a given instance and delete that instance entirely and just have your data on that volume, right? And so here you can see now that volume is in use, and you can see what it's attached to. And so here you'll see um, I'm able to create a total of 50 volumes. This allocation has 6, and you can see that 4.9 terabytes, that comes directly from this exchange here in the access allocations page, right? So 5,000 gigabytes, that's right here. And this is from the volumes, how much of that storage is being used right now, right? So the workshop example is still running setup. So let's see. So here we have public IT addresses, which if you are hosting anything, you can use to be able to reach it on a web page or something. So here, I do want to mention something about the images. We looked at it while we were creating um, the instance for the workshop. But one thing that I want to mention is, okay, here we have it. So when you create an image of an instance, it by default, now you can change, you can choose to change it, but by default, it will append the word image to the name of that instance, and that's what the name of the image is going to be. So these are, these arise out of, one specific way of manually creating an image. And, you can delete them if you find you no longer need them. But the same thing happens, and I'll show you what shelving unit is in a moment. The same thing happens if you shelve an instance. It basically it creates an image and appends the name shelved to that. And so if you shut down an instance that is running, which is essentially what shelving does, so that you're no longer going through your resources, then it'll create an image of that. And if you um, No, I would caution you against deleting these images or just exercise caution because this is because Jetstream2 uses these images in order to unshelve it, in order to bring it back online, right? So you're going to need those. And you can, when you're creating an image, you can change the name of that, but just keep in mind that the user created images are uh, they're kept side by side by the shelved images. So I just wanted you to be aware of that. Um, and so actually, since I'm not using this instance, I can probably show you I'll show you what it looks like. So here um, we have the summary of the instance here, right? So you can see when it was created, by whom, what flavor it is. If you need to see the specs again, then you can see them here by clicking on that. Um, the burn rate is probably one of the most important things to pay attention to. So as I've said before, um, the um, the Jetstream2 VMs, they depending on how big of a flavor it is, it will expend a certain amount of service units in an hour. And so because this is such a small one, it's the smallest one available, I'm only burning through one service unit per hour. But that's just for this instance, and that grows with the size of the instances and it grows with the quantity. And so you want to pay attention to that. But if you want to um, if you want to keep an instance, but you're done working on it for the moment, then you have the option of shelving it so that it's no longer burning through service units. So you're not wasting them. And so what you can do is you can go over here to the actions, right? And you have a series of options here. So you can lock it to prevent further actions until it's unlocked. You can suspend it, right? Or you can, so here's shelving it, right? You can shut down the instance and offload it from compute host. And um, shelving will stop your burn rate. It does take some time to shelve and unshelve. So it's not necessarily something that you would do like when you're stopped in the middle of the day to go away to lunch. But if you're done actively working on an instance and you don't want to leave it running overnight, then you can shelve your instance. And here's also where you have the option to resize, right? So you can change it to a different flavor. Again, not for full size GPU instances, but otherwise you should be able to resize in instance. So that's another reason why um, that's another reason why it's a good idea to start with the smallest instance that you need for your application. And here's where you also have the option to create an image of the instance, right? So if I wanted to create an image, I can change the name, but by default, it's the original name of the instance with the word image appended. But I'm not going to do that right now. And so here you can see a visualization of resource usage, CPU, RAM, root disk. So the CPU jumps up when you unshelve an instance or when you first create it. Here is where you have the option to the different types of interactions. So I don't use console, but here you have a web shell. This one in particular created without selecting the option for enabling the web desktop, and that's why I don't have that available to me. And you also have the username and IP address for SSHing into the instance. So if that's still running setup, then I'm just going to go ahead and show you logging into here. So that's Guacamole, which is software running the web shell. So when you first log in to your instance, it'll show you a status message. You can see that here it says active status items. Software packages fail to install or upgrade with apt. So that's what's going to give us trouble towards the end of the tutorial. So we're not going to be able to completely finish it, but I should be able to demonstrate most of it for you. And there's if you have the access to, you should have all access to the slides, so you can look through those for instructions on how to go through and serve up the web chat, right? And so here I'll show you some ways to interact with the web shell. Let's see, I believe it's a Control-Alt-Shift. Yeah. So if I press Control-Alt-Shift here, then it'll bring open this menu because and so it allows you to have access to a clipboard, and the reason for that is that the clipboard for this web shell, which is on your browser, is not shared by the clipboard on your actual local device. So if you wanted to copy and paste something, then you would have to go into here and, so for example, if I wanted to copy a command into there, then I would have to put it into the clipboard and then close out this. And then it should be, let's see, Control Shift V. Let's just Control V. Let's see. Oh boy. Should normally, let's see. If I highlight that, will it put it into the board? There we go, right? So highlighting things in the work shell puts it into the clipboard, but putting things in the clipboard should allow you to place things into the actual shell. Yeah, I'm not sure why that's not working that way, but that's because this is so cumbersome. That's actually why I prefer just the terminal on my local machine to the web shell, but it's good to have this option so that you can access and you can run commands directly through your browser, right? And so here, if you click under devices, then you have a little file manager here. So you can actually upload files from your local computer or download them from your instance, right? And you have some options to control it, right? So you can increase the font size. And if you're not working with a keyboard, then you can change the input method here, right? So there we go. You see? Now, I'll go ahead and show you how to install software. Now, if you're familiar with apt, that's normally an option. So like, sudo apt install, something. But if I try it, it'll probably fail out on me, right? And it doesn't seem to be failing. I wonder if I can. Huh. Okay, so we might actually be able to install things with that. So we might be able to get through the entire uh, tutorial example. Um, but yeah, so that's one way is to install things normally with apt. But Jetstream2 also provides you with a set of modules. So if you're unfamiliar with modules, it's a way to really quickly and easily configure your environment, right? So you can do module, let's see, should be available to list the available modules that you can select uh, that are here on Jetstream 2. And so you can see, oh, they have MATLAB here, they have R, they have a fair amount of compilers, right? RStudio, MiniForge. So what you're looking at here is you may notice that um, there are some of these modules have multiple versions. So for example, you have here R is version 4.4.1 and version 4.5.1. And so in these cases, you'll see that there's a D in the column to the right. And so the D indicates which one is loaded by default if you do not specify a version, right? So by default, if you load R without specifying a version, it will give you version 4.4.1 here, right? And you can also see that there are um, shortened versions of the module command. So I should be able to run mlav to get the same result. Yeah. And you can view just the defaults by, as you can see here, module you know, default avail. And so that just limits it to just the default modules. If I want to locate a specific keyword, I can use module spider, right? And let's see, let's look for RStudio, right? Just because I know it's there. And so it will show us RStudio and the available versions here, as well as a brief description, right? But how do I actually use them? Well, you would use module load, and let's load R. And now R is loaded. But in order to, if you want to check what you have currently, then it should be a module list. And here you can see that R is currently loaded as a module. So I should be able to run it, right? And so now I have R running in Jetstream 2. And so if you want to reset your environment, then you can run module purge. And so if I run module list again, then it shows me that no modules are loaded and I shouldn't be able to run R anymore. And so that's installing software on Jetstream 2. Let's see what it looks like here. Okay, that one's ready. So I'm going to go ahead and exit out of here. And you can just close it. So now I wanted to point out these. So remember earlier I told you, some options when you're trying to create an instance might be grayed out. Uh, you're going to want to, so here I got here from here, clicking on instances, and now it shows me this information right here. More than likely, it's going to be something like one of these where you've run up near to the limit of how many instances you can create, how many cores you have available, how much RAM you have available. And if the instance that you're trying to create uses more of any of these resources than are available to you, then it's going to be grayed out and you cannot select it. So there's that, and same here with, trying to create volume. So just, keep that in mind. So, by default, it will show you just the instances on the allocation that you have created. But you can go over here and clear filters and view all of them. And so here, these ones are shelved, right? That's what it looks like. And I'm actually going to, since I don't need this one, I'll just shelve it, right? And so here is an important point. If you are setting up your particular VM as some kind of web server, right? And um, if it's for example some sort of science portal, then maybe you would just keep it on all the time. But if you're not keeping it on, but you don't want to mess up anything, then you when you shelve it, you should uncheck release public IP address. So it'll keep it, and all of your settings should remain the same when you unshelve it. So I'm going to go ahead and shelve this, and here you can see it's shelving now. But I'll go back here and I'll go into this instance. And so here you can see, because we enabled the web desktop on creation, then we have the option to select it. So web desktop is also running on Guacamole. And here you can have a desktop with, RStudio and MATLAB running. And because it has internet access, you know, you can view, the latest. You can browse the internet in there, but it is a remote desktop. There is, your depending on your connection, it could be pretty laggy. And then if you could open a terminal, but at that point, you might as well just SSH in. So, so I'll go ahead and log out of that. And now, let's see. So those are the interactions. That's the history. There are no volumes attached, but you can also attach a volume through the instance itself, and it'll bring you to the exact same interface. Before we go into setting up the chat interface, just one thing I want to point out is that so this host name is essentially, where by default, at least, where you would connect, to to the instance. Here's your public IP address. So now I'm going to SSH into this instance just because I find the local terminal a little bit less cumbersome than the web shell. So you can simply just copy and paste what you have on your instance, whoops, and SSH into it. And if it's the first time, you may be asked to verify that you want to connect. And your password is located here. So I'm going to click Show and copy and hide that and go back here and paste it. And when you log in through the terminal, it provides the exact same, system status message as when you log into the web shell. So now I'm going to start running through the setup of the web chat interface. So this is, depending on your specific application, this may have varying levels of relevance to the work that you're doing, but largely it's just an example use case to demonstrate what you can use Jetstream to in order to be able to do. So here in order to speed things up, I'm using a set of commands and which once again I've shared the links to in the chat and had those codes up in the slides. So you should have access to all of these in order to be able to follow along. And as I've mentioned before, I've done some setup for this ahead of time. So I've set up some environments. So I'm starting, if you're following along in the notes, I'm starting in the post image section. Okay, you should have enough time to get through all this. So I'm going to begin by activating the VLLM environment and logging into Hugging Face. And so it's going to ask me for a token. So here I'm going to go to, let's see, huggingface.co. Here we go. So you're going to if you have a token, you can just use that. But if you haven't used Hugging Face before, I've had it, heard it likened to a GitHub, but for LLMs. So uh, I'm going to behave as if I'm doing this for the first time. So I'm going to create a new token here. And I'll say this token name, we'll say my access ID GS2 workshop example. Now you have a variety of permissions here. For our purposes, I only need to give it permission to this model. However, Whether or not you have access to the model will depend on whether ahead of time you had already requested and been granted access to this model. Now, if you do not have access to the Llama 3.21b instruct, um, don't worry. The steps for this tutorial will be exactly the same. You're just going to be using um, some different commands in certain places to use a different model that doesn't require permission to access. But if you do have it, then this is where you would select it, and you only need the read access here. You don't need to change anything else. So I'm going to go ahead and create the token. And once created, I'm not, this normally shouldn't be showing to anyone, but this is a throwaway, so I'm going to be deleting it later. However, this is the only window in which you will have access to this. So once you close this, you're not going to see it again. So at this point, copy that and save it somewhere safe. So I'm going to uh, open up a notepad. And so I've just pasted it somewhere else. And now, so I'm done with that. And here, see, it's been created. So I can go back here now and paste that. And for our purposes, we don't need to add it as a Git credential. So I'm going to say no here. And so it says that it's successful and it shows us the name of the active token, but we can double check that I'm logged in by running Hugging Face. Who am I? And there it has a username. So yes, I've successfully logged in. And now we can serve the model. So if you have access to if you have access to Llama 3.21b instruct, then you can see and you're following along in the workshop commands notes, then you would use variation 1 of this command. Otherwise, follow along with variation 2 using Tiny Llama 1.1b chat v1.0, which does not require permission to access. So I'm going to be using variation 1. And so I'm going to serve that model. And so these flags afterwards, um, they are being used to basically limit the amount of VRAM that this consumes. Um, because for a given instance, you only have so much. Originally, uh, these were used for um, a smaller Jetstream2 instance, a GPU instance, which no longer exists, which had less RAM than the G3 dot medium. And so this is going to take a little bit of time. We're waiting for a line to show info application startup complete. And once it does that, it should start printing out a message every 10 seconds, and it's not going to stop that. We're just using this in order to make sure that it launches without any errors um, before we turn it into a service. Okay, there it is. Give them a few seconds to start printing. There it is. Yeah, so it's just going to do that every 10 seconds. So I'm gonna kill it with Control C. And so now we're going to do the exact same thing, but create a service for it. So you're going to create a file at the systemd system and call it vllm.service. And once again, if you are using Llama 3.21 vInstruct, then use variation 1, otherwise use variation 2. So I'm going to paste variation 1 here. And so this is just creating a service for it, and you'll notice it's the exact same command right here, right? So I'm going to save that and close it out. And so first I'll enable it. And then we'll start the service. And so that will launch the exact same command, but have it running in the background, right? So we can see if it's actually doing what it's meant to be doing if I run NVIDIA SMI, right? And so what we are expecting to see is here in the GPU memory usage. So you see it's starting to spin up basically, and it should increase to what was previously about 8 gigabytes, but I think it keeps growing. But that's what, so basically that's what we're expecting to see. I think with like each update to VLLM gets, the memory usage increases, but eventually, as long as it hasn't failed, it should plateau at a certain point that's less than the available VRAM of the instance itself, right? So I'm going to kill that with Control C because it's showing me what I want to see. And so that's all we need to do with the VLLM. Now we're going to configure OpenWebUI. So I'm going to activate the OpenWebUI environment that I've already set up before. And here we're doing basically the exact same thing. First, we are running it to make sure that it runs without any errors, and then we're turning it into a service. That's what we've been waiting for application startup. So here, this one doesn't print a message out every 10 seconds. But once you see that, then you know that it ran successfully. So you can kill it again with Control C. And so here we're going to create a file at C systemd system and call it webui.service. Should be called WebUI. Yes, it is. So enable it and start it. There we go. So that was a VLLM and WebUI. The last thing we need to do in the terminal is caddy Now, installing Caddy involves using apt. So, um, whether or not this will be successful will depend on whether or not app will run successfully. So let's see if it does. I think it might fail. So VLM is to um, serve the model. Web UI, Open Web UI is to uh, run the interface, and then Caddy is to actually run the HTTP server. But let's see, is this working or is it not? Normally, it wouldn't take this long. So I think, yeah, error processing package. Most likely, this is failing, and unfortunately, that probably means we won't be able to finish installing Caddy, which means I won't be able to actually show you the web chat interface. However, if it does ultimately fail out, um, you can try from scratch. Yeah, this has failed. So you have there are pretty detailed instructions in towards the end of the slides for how to go about this yourself from a totally fresh instance, actually. And I think, yeah, I think it actually says here that completely new instances should work. Um, so you may have more success starting from scratch. But if you have the slides, you have links to all of the resources to be able to go about this yourself. Unfortunately, I would have liked to have shown you the end result. It should have been, a website that we can access through the browser, and we're able to go back into the browser and interface with the chat that we set up on our Jetstream2 instance. Unfortunately, I'm not able to show you that. And so what remains is I think that that is uh, functionally it. We do have about 11 minutes remaining. Here you can see this is a larger flavor, G3.medium, so I am burning through 16 service units an hour. I do believe that's it for Exosphere, but I do have a few slides remaining here. So, those of you who I've added to the workshop allocation, I'll leave you on it for a little while, about 24 hours, maybe less since we're going into the weekend. And but so you'll have the chance to do some experimentation. But I ask that when you are done, you shelve or delete your instances once you're done, and then you will be removed afterward because we are starting to run low on at least this parcel of available credits. So after that, you'll be removed. However, you have other options for continuing to experiment with Jetstream2. There is a trial allocation. So you can follow the link here and use your access ID to sign up for a trial allocation. It is limited to 90 days and one M3.tiny or one M3.small instance. But it's a good way to get used to working with Jetstream2. Uh, and of course, then you can, go on and submitting a request for your own allocation, which actually is a good use of my remaining time, is showing you the page for uh, actually requesting an allocation. If you come in here, you have no projects, but you wanted to request a new allocation, you go over here, request a new project, and so you have Explore, Discover, and Access immediately available to you. And yeah, they recently added a an option here for maximize, and that's what discretionary means, but Explore should demonstrate the minimum requirements and that it takes to submit a request. So here you can see this is the actual form that you would be submitting. So you would need to provide a project title, a public overview. This is like a little more than an abstract, really. Some keywords, your planned usage for this, some optional questions, but it helps them out to, provide this information. This is the point where you would list any co-PIs. You can add an allocation manager after the fact, but it's a hassle to add a co-PI to the project. So you would want them to have already created access counts so that you can add them here while you are submitting your request. And then if they're outside of Access, you can identify your collaborators here. If you do have a supporting grant, and this once again, um, Jetstream2 is NSF funded, so you're not paying for this yourself, but they do want to know, so provide information on your supporting grant here. And so at minimum, you would need to provide a CV or resume for the PI and co-PI. If you are an educator and using it to teach a class, include a PDF of the class syllabus. And if you are a grad student, then you would include your advisor letter here. And then finally, you would select access credits and then, click save, right? And this form gets longer and the demands just increase as you apply for larger projects. So, so a lot of the useful information for helping to prepare a project is here on, prepare requests or, all of this information or getting started is good. So you'll notice, an explore request. This is basically what we just went over, but that list just grows as the size of the allocation grows. So an explore request is, basically a summary. Um, Discover, I believe, is a one-page description. Accelerate is a three-page description. And then I believe maximize is a 10-page description. So there's a lot of good information in submitting your request here. And if this is your first project, then you could also just go here and this lays out some of the same steps that I mentioned earlier. But yeah, that that's essentially it. So here you can see I've provided a bunch of links to various resources to help you on your way. We have about 5 minutes left. Are there any questions? All right. If there are no questions remaining, then I'll give you back 4 minutes of your time.